roll in, but we've got a couple hours, so I do not want to watch the transcript. Thank you. So thanks for coming out. So this is the start of a 4-session series on R4 health data science. Thanks for your interest. This is a fun session for me to teach. I did it the first time just over 3 years ago. It was the first winter of COVID, and I did it mostly because I was just craving interactions, wasn't teaching that winter term, and that was a chance to talk to people every Friday. So that was as a weekly session. So this is a little more intense. That was 10 90-minute sessions. This is 4 3-hour sessions. So I'm going to try and break things up a little more. Try and do at least 20 minutes to half an hour of kind of breakouts each hour, but different modules will take different amounts of time just based on that. So I guess I should ask at first, you've all taken Biostats 1 and 2. This course is designed for people who have taken Biostats 1 and 2. So certainly, like we cover Biostats 1 on Friday in about 2 hours, like just the how to do the methods. But I don't have to teach you what a t-test is or a linear model, or I think we get all the way through Poisson models, so a little bit into Biostats 2. When we talk about mixed effects models I think that's the last lecture, the 4th session, I might take a little bit of time just as a refresher in case you guys haven't, or actually, no, you guys didn't do mixed models, did you? In Biostats 2, you did generalized estimating. But we're a ways from that. So for today, I want to talk about beginning to use R, learn the principles of statistical programming, some of the basics of like how to get how to get things created, how to get working with objects, how to start manipulating data. We won't be doing any kind of, we won't be producing much today. A lot of it is learning how to use R, learning how the interface of RStudio works, and then data munging, getting data into the format you need so that you can do analysis. I should have cut that out. I think we're going to do that next lecture. We're not going to get to graphing in this lecture. So before we begin, make sure you have R and Rstudio downloaded. Make sure you can launch RStudio. You don't have to launch R. If you just launch RStudio directly, it uses R. So R is the actual software you're using. Like when you write a paper on your analysis, you would say all analysis is done in R version 4.x.x, whatever version you're in. RStudio is just the environment. RStudio adds nothing to the process. I shouldn't say nothing. It's very helpful. But as an analytic tool, everything you write in RStudio, you could take and run in R, or run in Visual Studio, or run in, there's a fancy notepad called TinR that you could use, Emacs, or Vim or GVim if you really want to get into the 90s era computer nerd programming. Like any program can run R scripts. That being said, RStudio is the best one. It's by far the most developed. It's the most common now. I did most of my both of my thesis developments in Emacs because RStudio wasn't out yet. But once RStudio came out, I finally made the switch, and it's just a better environment. And I'll kind of point out the things it does that are better than base R, but there are little quality of life things in RStudio that just make it so much more. Once you've done some programming in RStudio, if you have to go back to base R, you're just going to be really annoyed with like basic things like autocomplete's not working and the help file not being integrated and all those useful things. All the course material will be on the course GitHub. Looks like this. If you really want to get into GitHub, feel free. There's some good guides on how GitHub works. If you just want to click on things to download them, that's also fine too. So if you want to like pull the file, or to tell you the truth, I don't know Git as well as I should in terms of its version control ability. I'd also just use it as an easy way to upload a bunch of files at once to a website, which is why I'm not using Blackboard, Brightspace. Because just uploading multiple files to Brightspace is a pain. And I do find that the course material changes for this course. So don't download a lot of the session 2 you could probably download, but I might change the session 2 stuff before next time. Session 3 I might change. Session 4 I definitely will change because I haven't figured out exactly what we're doing for that one yet. Uh, I will attempt to webcast each session. I looked at the last time I did this, I was 8 for 10 on successfully recording videos in my 10 sessions. I messed it up twice. Uh, they'll all be uploaded to YouTube, available in a playlist. I can't figure out how to create a blank playlist in YouTube. So there will be a playlist of these 4 lectures, but I can't figure out how to make a playlist in YouTube without having a video to put in it. So I'm going to wait till I upload this video after class, and then I'll have a playlist, and I'll share that with you then, and fix these slides to have a link there. I will say, figure out, I didn't try too hard. I went to my YouTube developer page, and I couldn't see like a new playlist button, and I was trying to work on other things. So R as a statistical programming language, first published in 1993. It was built on languages S plus and S were the original precursors to it, but R came out in 93. It's comparable to SAS, SPSS, and Stata in that that's kind of the world it exists in, but they're mostly analytic in nature. It's the only one of these kind of big players that can function as a pure statistical language. I think it's the only one that passes the Turing test where it can trick you into thinking it's not a computer. It's the only one that has object-oriented programming that can execute non-statistical programs. In that sense, it's more comparable to Python than SAS, although when you start comparing it to real programming languages, it does have its significant drawbacks. So, it's a very kind of in between the statistical languages and the real object-oriented computer programming languages. I use it for a lot of object-oriented stuff. I use it for a lot of things that I probably should use Python for, but that's because I just don't know Python that well, and I know R a lot better. It also has the steepest learning curve, particularly if you have no programming experience. So this first lectures might be tough if you don't have a lot of programming experience. Feel free to ask questions. I'm going to try and frame it, take my time with this first 2 hours and make sure you're getting basics.
Hi, Sam. I think we can't hear you for some reason.
There, can you hear me at all right now? All right. I got this awesome wireless mic from computer science, and it then died a couple minutes in. So it's just looking for some batteries. So we'll switch back to the good mic in a second. I'll try and stay near my computer for now. So yeah, what I was saying, if you go to pane layout, I would put source on the left and console on the right. Do whatever you want. I'm not picky, but those are the two windows you use by far the most. So having them on the same side means that the left side of your screen is just wasted. If you put source on the, you can do it either way. You can. There's also a button that I do sometimes use. This little button right here. That'll pop your script out to its own window. So not a lot of use when we're all working on laptops, but if you're working on multiple monitors and you want to see a lot of code at once, you can do that to put all your code in one place. Yeah, and so I mean, you can see I prefer a dark theme, so Cobalt's the one I'm using, but all right, we're doing well. We got no mic and no screen for the people online, so let's see if we could just working a little bit. Get that out of the way. There. So R is a workspace language. And what I mean by a workspace language is when you run a command, it produces an object that is stored in an active workspace. That is similar to data in that, you know, when you run a data command, it creates a data set. SAS is similar when you create a data set, or create multiple data sets exist. Even so in Stata, even models, right? When you run a model, that model exists in the space. We don't tend to use it that way in Stata, but we can get those batteries. Awesome. The nice thing about R is that it's more than just data that exists in the workspace. Everything exists in the workspace. And because it's a relatively object-oriented language, I say relatively because it's not, we'll see. But I mean, I can get away with calling it an object-oriented language if none of you know computer programming, because we won't get caught up in the details of how object-oriented it is. I'm going to switch to the other mic. Can you guys still hear me? Yeah? Okay, great. All right, so yeah, so object orientation. When we run a command, x equals 7, it creates something in the workspace called x. And we can make it a string, we can make it a number, we can make it a bunch of different numbers. So if I run those 3 commands, we see I now have an object called x that has the value 7. I have an object called y that has the value string, just those characters. Z is actually 100 different random numbers between 0 and 1. And I'll talk about how those functions work and what exactly I called there. But this idea of object orientation, a create a thing exists, it's really important to get your head around. One of the big differences with R compared to Stata and SAS in particular is when you run a linear regression model in Stata, you get a bunch of output. Right? When you run a linear regression model in R, you get no output. It creates a linear regression object. And that has all the summary statistics, it has all the information about the model you would need, but then you have to create the summary yourself. It doesn't naturally produce it. That's a big change from something like Stata, and particularly SAS. SAS is famous for producing a ton of output on all of its, like a 2x2 table with a chi-square test in SAS is like 6 tables and 2 pages worth of output, where in R, it's very minimal. The output is very minimal. It's up to you to create the output yourself. So this idea that the primary results of function in Stata is output, right? When you run a command in Stata, you get a printout. When you run a command in R, you get an object. And that object has all the information that would be in that printout, but it's up to you to extract it. That lets you have a lot more control over your reporting and the objects you produce, but it does put more onus on you to dig into those objects yourself. So data types, what do we store data as in, I have more space here. What do we store data types in R? There are 5 basic data structures I'll talk about. Scalars, vectors, matrices, and data frames. Talk about them, and then finally. So we'll start with scalars. Scalars are, also talk about the basic number types, I guess, before I get to that. We need to know kind of what the basic object types are. This is what variable types are. That's the data right there. I'm going to stop right there. I don't know what the variable types are called. That characters and factors and numbers. I don't know what the full names of them are, but we think of them that way, right? We have numeric variables. We have character variables. Stata actually kind of messes up character variables. Like, you shouldn't use character variables in Stata. You probably shouldn't use character variables in R, but R will work a little better with them. Stata gets really wild with it when you have character variables if you don't convert them to factors yourself. And from an analytic perspective, you do need them as factors. So it's not a huge drawback, but I do find Stata gets a little wild with it if you actually have something stored as a character. So we've got numbers. They're called numeric in R, and R doesn't make a big difference about things like integers, doubles, floats, like the different kind of really nitty-gritty computer science details on numbers. They do have differences, and if you're running into those problems, let me know. But if you're not, it's just numbers, and they're most comparable to, I guess, the computer programming concept of doubles, in that they can be decimals. True/false values are just capital TRUE and capital ALSE, and they're called logicals, but they're just true. The words true and false, no quotes in capital letters. Strings are words enclosed in either single or double quotes. The dolphin and another dolphin. The program I'm using typeset quotes, so they're kind of weird. But you can see when you look at it in that R script, it's just that's a single quote, that's a double quote, and there's no difference. So there's no difference between imposing a string in a single quote or a double quote. And of things I'm about in R, I have no consistency whether I use single or double quotes. Switching back and forth, sometimes within the same line. It's just the only real advantage of it is if you're typesetting something with an contraction like don't, right? If you have a string that has a single quote in it, surround it in double quotes, because you can't surround it in single quotes, because then the single quote will end the. So that's the only real place that ever comes up, is that if I need to typeset a quotation, I'll put it in single quotes. If I need to typeset a contraction, I'll put it in double quotes. I'll also just, depending on which key I feel like pressing, because they're the same button, just whether I feel like pressing shift or not. So I talk a little bit about variables. I said everything can be stored in variables. So that's the left side of the equals. Or if I go x equals 7, I'm talking about the x side. All objects are stored in variables. Almost any combination of characters can be used as a variable. And I would encourage you to use descriptive variables, right? If you're creating a vector that's like an index of rows for a data set, call it ind or index. Don't just call it x, right? Try and avoid using x, y, z, despite the fact that this first script I'm giving you uses x, y, z a lot, right? When you're building models, call them mod or model or mod.int for model interaction. Like, be descriptive. There's no limit to how long they can be. And the more descriptive your variable names, the easier it'll be to come back to that script, a week or a month from now. Because no matter how much you think you're done with a script, you're never actually done with a script. I have 15-year-old scripts that I'm still going back to steal certain code from, or I know I did this thing and I need to go back to it, or I don't. The way that I do generalized estimating equations is usually to go back to the last time I taught generalized estimating equations, and that was like 6 or 7 years ago. And I just steal code from that because I made the effort to do it the right way that time. In terms of what you can't do, you can't have spaces. It can't start with a number. So I can have mod 1, but I can't have 1.mod. It can't start with a number. It has to start with a letter. There are some symbols you can't use. I know $, hashtag, the @ symbol you can't use. I don't know if a question mark works. In general, we use letters, upper and lowercase letters, upper and lowercase of just numbers. No such thing as a lowercase number. Dots and underscores we use a lot as well. You'll find I tend to do a lot of my variable naming in camel case. So have any examples here? I don't think I did any. No. But if I were making a variable of provincial capitals, I would do prov capitals and use a capital letter, a capital C in the middle. It's called camel case because you get these humps at new words. That's just a remnant of when I used to program a lot in Java, and Java doesn't let you use dots. So I would say the more common naming convention when you're reading other people's R scripts is either to do prov dot capitals. It's not going to do anything. Or that would be kind of the two ways, the two kind of conventions that people would normally use for naming things. But if you want to do camel case as well, that's fine. Whatever makes it readable for you, I think is the best. Neither of those are going to do anything. Oh, assignment. You'll see here, I assigned x equals 42 and x2 arrow. So this is literally just drawing an arrow. It's a greater than sign and a minus sign. Combine, it's an arrow. Both of these assign the right value to the left value. It's a legacy of, I don't suppose anyone knows here, C programming. It's a legacy of a bygone era. This actually these were very different in C, whether you were assigning a pointer or assigning the value of the pointer. And I don't want to get too deep into that because it'll expose the fact I never really understood the difference. But for now, in R, these both work. And they both work just because R has a real dedication to backwards compatibility. All the code written in 1994 should still run on the 2024 version of R. They're very dedicated to backwards compatibility. And we'll talk a couple times, not this lecture, next lecture maybe, about places where there are some frustrations with how we use R that are because of backwards compatibility, right? The built-in ANOVA command to build like an ANOVA table for a regression model builds it the wrong way, I think. And almost every statistician agrees with me that the way it builds it isn't the way you would choose to. But when they programmed it in 93, that's what they did, and they don't want to change it because that would ruin backwards compatibility. So you'll see the arrow assignment a lot maybe in code you download. I know I once stumbled across Google's, like the company's internal R coding policy document. And their standing policy was to use arrows as assignment rather than equals. I prefer equals. It's half the characters to type. And I don't know, I just think it looks cleaner. So I'll mostly use equals, but this also works as an assignment, that arrow assigner. And they both just exist for backwards compatibility. So those are all examples of scalars, right? It's a variable equals a single thing. We're not going to use that much, right? We're not going to assign things as scalars all that often. Vectors we use a lot more. Vectors are just sets of numbers. You know, what do you call a vector or an array? We call it vectors in R, but array is a similar concept. So C stands for concatenate, and that's how we just stick a bunch of things together. So if I do this, X becomes a vector with 3 elements. The first one is 21, the second one is 2, the third one's 42. We can use this colon operator if we want to demonstrate all the values from 1 to 10. So y equals 1 to 10 just does 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is just a selection of strings. So we can see that when we run this, if we look at X is just a vector of 3 elements. And the first element, the third, fourth, fifth, we reference individual elements with square brackets. So X square bracket 1 gives you the first element. X square bracket 3 gives you the third element. If we try and reference an element that doesn't exist, so you can see Z had 1, 2, 3, 4, it had 4 elements. If I try and reference Z5 or Z0, we get NA, and NA is the default missing value in R. You'll encounter NAs a lot. It's particularly when you're reading in data and you have missing values, you'll want to code it as NA. And NA just means missing or not applicable is what it stands for. So if you try and reference an index of a vector that doesn't exist, you just get, you don't get an error. Like it doesn't tell you you did something wrong. It just says the fifth element of Z doesn't equal anything. Math is done with pretty basic operators. Exponents are performed either using the caret, the little hat, shift 6, or two multiplication symbols. This is something I learned while preparing these slides. I've never done an exponent that way, but feel free if you want. It should be pretty recognizable. Comparison. So if you're doing, Boolean logic or comparing if things equal certain values, two equal signs is how we compare if things are equal. This is not equal, and then less than or greater than are a little more intuitive. You can do less than or equals just by combining the less than and the equal symbol. And then we can combine comparisons with ampersand is an and. So if you combine, I'll just show you. It's easier to talk about it on this slide. So I'm going to x is 7 and y is 5. So the basic math operators, plus, minus, times, divide, exponent. Those are all straightforward. And now we've got the Boolean operators. So x equals y asks, does x equal y? And then the return should be false because x doesn't equal y. X is 7 and y is 5. If I ask, does x not equal y? I get true because x does not equal y. So it's asking if x equals y, and we get that. We could also, and I would say we probably more often, rather than comparing two values, we compare a value to a constant. So if I ask if y equals 5, I get true because that is the value of y. These last three examples of how we combine things. So the ampersand is an and. So this line will return true only if this is true and this is true, right? So is x not equal to y and is y equal to 5? Well, we know x is not equal to y because x is 7 and y is 5. And we know y is equal to 5. So this line should return true. But the next one will return false because even though this first part is true, the second part isn't. X is not equal to y. So we get a true and a false. Yes and no means no. Finally, the single vertical line means or. So if this is true or this is true, the entire thing is true. So in this case, we do, this one is true because x is not equal to y. This one is true. This one is false, but true or false equals true. So a little bit of, you can get really deep down the rabbit hole of how complex Boolean operators go. When we talk in the third hour today about dplyr, a different library for manipulating data sets, we actually do a fair bit of Boolean logic in terms of filtering, like subsetting our data set with Boolean logic. And you'll see a little bit more of that in a couple hours. Next up, we've got matrices. So matrices are two-dimensional structures of rows and columns. We still reference things using that square bracket notation, only because, so with vectors, we only exist on one dimension, right? So it's just first, second, third, fourth, fifth, sixth, seventh element. With a matrix, we exist on two dimensions, right? We've got the rows and the columns. So if I want the third row and the fifth column, we'll go 3 down and 5 over. I reference it with x3, 5. That gives you the value of the third row, fifth column of x. To create matrices, we need the matrix function. So you can see here, I'll talk a bit about functions in a second. So I made matrix. I took the values of 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I made a matrix with 2 rows. And then I populated it by row. So my first row goes 1, 2, 3, 4, 5. And then my second row goes 6, 7, 8, 9, 10. You can see that I printed it out over here. Conversely, for this one, I did 4 elements. So A, B, C, D. I again made it 2 rows. But I went false. So rather than going 1, 2, 3, 4, 5, I went A, B, C, D. So I populated it by columns rather than by rows. It's not a command you're going to use all that often, but I want to talk a little bit about functions because functions really are core to your understanding and being able to use R. And they're a little bit different than Stata and Sass. Both Stata and Sass Stata in particular use space-based indexing, right? So when you're working with Stata, you've got a command and usually a list of variables. I don't have a good sense of when an argument falls before or after the comma in Stata. Like, it seems like variable manipulation is before the comma and model manipulation is after the comma, but I'm sure someone who's like an expert or works at Stata could explain why certain arguments come before or after. But then after the comma, you would have some arguments about like no print or OR if you want to get odds ratios instead, right? So you've got those arguments. All the same stuff exists in an R command. SAS does it with the different lines with the like the class statements and the model statement and all the different statements per line in SAS. R does it as a more traditional bracket-based programming language. So R looks very much like Java or C# or Python to an extent. Python uses a lot of indentation, where you have a command, then surround it in round brackets, and then you comma separate all the individual arguments. So if I show you the help file for, if you want to see the help file for any command, you can either type help matrix, help, and then the name of that command, or just the question mark, then the name of the command, and that brings up the help file. So you can see here, I don't think I can make this one any bigger. Yeah, so you might want to look at it on your computer because I can't make it any bigger on my screen. There's no font button on the help files. But you can see that we've got data equals blank, and then nrow equals a number, ncall equals a number, byrow equals false, dim names equals null, et cetera, et cetera. Okay. And you can see sometimes they're default arguments. So you can see here that nrows default is 1, ncalls default is 1. So if you try and pass it a matrix with no indication of what the dimension should be, it defaults to 1. And like dim names defaults to null. Byrow equals defaults to false. So if you don't tell it to, it populates your matrix by columns. It does the first column, the second column, and the third column. So all of the help files follow the same general structure. There's a description of what the command is. Usage is how it is, all the different ways it works. And then the arguments describe each of the arguments to that function. So it explains what it wants out of the data argument, what it wants out of the nrows and the ncolumns. And then at the bottom of that help file, there's an examples page. And I would say that the two areas you're going to use the most are examples and the one at the top, arguments. I'll also say that I find the typesetting on these, as you can see, a little bit small, and it's web typeset, but not an actual web page. Like, you can't, harder to bookmark it. There are a ton of different services have taken this entire help file and just put it online. So if I just Google help matrix. Yeah, this is the same. This must be the one I go to the most, our documentation.org. Just a prettier typesetting of that page we just looked at, and now I can leave it open in a tab. So I will say that I don't use the help function within R all that often. If I want to pull up the help file for a function, I usually Google it, because I just want to get to this page because I can save it a little easier, and because it's a little easier to read, like better spacing. It's got things outlined. It's got the example scripts all working. You don't have to do that, and I certainly do. If I just need a really quick bit of help, I will use the help file. But if I'm looking up a function because I don't really know how it works, I will Google it. Also, because I'm going to Google about 15 other things while I'm trying to figure out how this works. Google is really your friend with this in a way that it isn't for Stata and SAS. The community is way larger and way more helpful. If you don't have a Stack Exchange account yet, create a Stack Exchange account, only so that Stack Exchange doesn't bug you every time you click on it to create an account, because you're going to be at Stack Exchange a lot. It's just a place where a lot of the answers. So I find myself often Googling R, ggplot, how do I do this? Because I can't figure out how to do a specific graphing function. Or R, dplyr, you guys don't know what dplyr is yet. How do I manipulate this? And there's almost always someone who has had the same problem, and then 3 other helpful people that have explained to them how to solve that problem. So Google is very much your friend when looking for help with R. And one of the challenges you'll learn as you go on is what are the good and bad websites for that. You know, Google's learning algorithm will learn from you, right? The more you visit like Stack Exchange, and there's a British website, I think it's called STHDA, all those letters are involved in their acronym. I can't remember where they go. They have a lot of really good like intro to graphing and intro to data manipulation, like for very specific functions. And I find I never go to their website, but I end up at their website all the time. Oh yeah, that's the other thing that you can do in one of the best things about RStudio is if I start typing matrix, I get this pop-up. And there are a bunch of different things that'll pop up, but it tends to get the right name first. If I just pause for a second, a tiny little help file pops up here, which is really helpful if you know how the argument works, but you just can't remember, is it called nrow? Is the argument called nrow or numrow, right? One of the ones I always forget is there's an argument when you're reading in data in the read Excel command, if you need to read in Excel data. I want to tell it how the Excel file has stored missing values. And I can never remember if it's NA.strings, NA_strings, is it NA, is it capital NA? Like I know there's an argument, but I just can never remember what the actual field is called. So if you do this and just pause for a second, all the arguments pop up. The other thing you can do is if you, it's not doing it now. Okay, get out of there. Too many hoverovers. Yeah. It will sometimes auto-populate this. Sometimes you have to press Command Space to auto-complete it, where it will try and complete the argument you're working on. So again, if you're working in a function and you're like, man, I know this function has an argument that has the word row in it, but I can't remember if it's nrow or numrow or n.row, whatever it is. If you start typing row, so we go data equals 1 to 10. Yeah, you have to get it. It's not a super smart search function, but I'm just gonna kill that because I don't want this command. You'll learn to use that hover over, and is really helpful with functions you know how to use. It's obviously there's not a lot there for like if you try and move your mouse over it, you're gonna break the hover over and that. But if you know how a function works, but you don't have the arguments memorized, RStudio can be really helpful there. So what are we on to? Oh, variable types. We're on to factors. So categorical data types. There's no sense of ordinality here. We can talk about how it handles ordinality, but for now we're just talking about categorical variables like hair color, province, things that have no inherent ordering. You don't have to dummy code anything. This is something that I used to have to tell everybody, and it is increasingly not a problem. So if you've worked in SAS or Stata, you guys haven't tried to like create a like this variable equals 1 if province equals Nova Scotia, this variable equals 1 if province equals New Brunswick. Like that's how your models are going, like that's how your regression model is going to code it in the back end when you build your regression model. But we don't need to do that. R takes care of it. And I used to have to tell everyone that. But I don't seem to have to anymore. It seems like all of the statistical languages are handling this well now. So it's just, we have these factor variables. Obviously, the factor variables are important, really important to get them sorted correctly and do things like getting the first level. So when I run a variable, like when I run a model like this, you can see the difference. Prov was just a set of strings. Prov.factor is a factor variable that has 4 levels. And in this example, New Brunswick is my first level. And New Brunswick is my first level because of the alphabet. Yes. So it's just sorted them alphabetically, made New Brunswick the first level. That's fine. I don't know. You might want to choose Nova Scotia because it's the biggest, or PEI because it's the smallest. Depends what your purpose is. But when we go to run this in R, like if we're doing a regression model and province is one of our factors, New Brunswick's going to be the reference. But we're going to get coefficients for the other 3 provinces. And it's one thing I kind of, both a blessing and a curse in Stata. You know how Stata lets you, it's like IB number before a factor variable to change the reference level. It's not that easy in R. You have to rearrange your factor levels to make whichever one you want to be your reference to be the first one. So it takes a little bit more planning up front if you want to change your reference level. So on to data frames. So data frames are what are most like the active data set in Stata or just data sets in SAS. So one of the nice things about R, and one of the things that SAS and R programmers get the most frustrated by in Stata and SPSS is that single active data set. You've probably run into this problem. You might have run into this problem yourself where in Stata, let's say I want to do a sensitivity analysis just restricting on a certain, like I just want to do a sensitivity analysis just on males or something. If I subset my data set, like remove all the females, there's kind of no way to get them back, right? I just get rid of them. And then if I want to do another sensitivity analysis, I have to go back and load my data set again. There are other ways to do that. You can subset within commands. So you could subset within your linear regression command rather than at your data set. But another place that it could be very frustrating in Stata is if you need to switch from long to wide data. So you know what I mean by long data? So wide data is when you have one row per subject and a bunch of different columns, like first visit blood pressure, second visit blood pressure. Long data is where you would have one row per observation. So subjects would be on multiple rows, but you would have like visit 1 blood pressure, visit 2 blood pressure. So we often need to switch things to long format to run things like generalized estimating equations or mixed effects models. And in Stata, once you switch your data to long format, it's in long format. And you can't go back to the wide data set. So if you need to kind of rerun your script. And this idea of an active data set, SAS doesn't have SAS has an active data set, but we don't use it. Like you always specify your data command for each function. You should. And you could have multiple data sets active. So in R, data sets aren't special, right? They're just another object, right? So much like x equals 7, dat equals your data set. So it's helpful there because you can have a lot of different active data sets, but you do have to keep track of them. So data frames, and I'll talk later about something called tibbles, which are like data frames, are the most natural approximation to spreadsheets. They're very much like the data sets you're used to in that they look like matrices, right? Rows are subjects, columns are variables. Matrices are restricted to one data type, where data frames aren't, right? You're going to have a different data type for every column. Your research data will almost always be stored in a data frame, right? It would be, I could probably count on 2 hands the number of data sets I've used, the number of research projects I've used that don't use data frames. And almost all of those are because I'm using R for something I should have used Python for. So there are some times I've done like pulling things from the web or processing XML files, which R can do, and they do it okay, but other programs do it better, but I was just lazy about it. So we can see that I've created 4 variables. W is just the numbers 1 to 4. X is just 4 letters A, B, C, D. Prov is that's that vector I created before, the random provinces, and I just picked 4 of them. One of the fun things that I use a surprising amount, there are some built-in vectors in R. So if you just type those in RStudio right now, you'll have them. They just always exist. So if you need like random letters or random factors for something, you can use those 2 vectors. They're just always kind of hanging around. So if I get this out of the way.
Can I interrupt with a quick question?
Sure, yep.
Sorry, when you did the that province variable, I just couldn't quite understand what a factor variable is and how it's different from when you did like the string version of the variable first.
Sure, yeah. So here, I'll pull them up just so you can see them. So the string variable is just the strings. It has no underlying structure. A factor variable, underneath what it's done is it's assigned all the subjects with, I got the order different that time. Weird. It assigns all the subjects a number. It sort of assigns all the levels a number and then a character to that number. So underneath what it's done is it's made all the New Brunswicks a 1, all the Newfoundlands a 2, all the Nova Scotias a 3, all the PEIs a 4, and then it associates those with those numbers. The other thing it does is when I put this factor variable into a regression model, it will naturally do the dummy coding correct, so I'll get coefficients from my last 3 numbers. Character variables don't do that. So you can see that if I convert a factor variable to number, it will reveal that numeric coding I was just talking about. So you can see that the 2 Nova Scotians got values of 3, the 2 New Brunswickers got 1s, the Islander got a 4, et cetera, et cetera. So it has this underlying numeric coding. It won't use that, but that's what's there. If I try and convert the province to a factor, to a number, it just breaks because there are no numbers there. What it's actually trying to do is it's taking the actual strings, it's taking NS and saying, is NS a number? And if it is, it will convert it. So something that will come, you will encounter this, you'll have to do this, is as.numeric to. If you have a number in a string by accident and you run as.numeric on it, it says, hey, is that a number? And if it is, it'll convert it to a number. So often that will happen if you've read in a variable that you thought would be numeric, but while reading it in, it encountered some characters it didn't expect. If R wants to read in numbers, but if it encounters things that aren't numbers, it reads them in usually as characters. So that's a big difference, is that the factor variables have this kind of underlying structure. I don't have any factors in this yet. They have this underlying structure where they've assigned values to levels, and then those replace the characters with the numbers that corresponds to that level. Does that help?
Yes, thank you.
Okay. Yeah, so back to our data frames, we can see that I created just a number, a character, 3 characters. And then I assign them to a data frame like this, or I can assign them actual names. So in this one, since I didn't give the 4 columns names, it just named them W, X, Y, Z, because that was the name of the vector that was going in. I could name them as 1st, 2nd, 3rd, 4th as well. So I can reference, remember we were doing square bracket referencing. I didn't show you this before, but when you're doing square bracket referencing and you leave a field blank, so 1, nothing, gives me all the observations in the first row. And nothing, 1 gives me all the observations in the first column. Now I can still do individual cell referencing, like df1, 1, 2. That would give me the first cell, second column. I can also do multiple numbers. You can see that if I feed 1 and 2 as the rows and nothing as the columns, that gives me the first 2 rows and all the columns. So we can do all the referencing we want. The other thing I want to talk about with data frames is the $ operator. So that's how we can reference the named columns of a data set. So if I want to reference so df1 is the data frame. If I want to reference the column named W, I would df1 $W. So that's how I reference the objects within a data frame. There are other ways to do it, but the $ operator is the easiest. So we can see df1 $X gives us the column that was named X. which was the third one, right? Second one. df2 $third would give us the column that was named third. And we can use that for assignment too. So we can see that df2 has 4 columns. If I create a column with the title 5th, and then look at df2, we now have 5 columns. And if I create a column, so I'm last, it creates a column called last. So we can, the $ operator is how we reference the columns of a data frame. And we can do that to either pull them out. We can also do that to assign them if we haven't created them yet. So the final structure, and lists are kind of, they're a general structure for anything or a mix of things. When you run a regression model, what you get back is, it's not exactly a list, but it's mostly like a list. There's kind of bags of stuff. They're indexed, like they have a first element, a second element, a third element. Those elements can be named, but they don't all have to be the same type. So you can put, they become increasingly useful as your programs become more complex. So I'm working on a project with Dr. Hayden on a meta-analysis. We have the individual patient data for 17 or 19 studies. So I have 19 data sets. A lot of my work when I'm working with that, I'll put all those data sets in a list so I can just keep track of them better. Rather than having to type out 19 of them, I'll operate on a list and like iterate through that. So there are lots of different reasons you might use lists. I don't know if we see the apply functions today, but the apply functions often return lists. So you can see that when you create a list, it actually looks a fair bit like creating a data frame. And in reality, if you kind of dig into the back end of our data frames and lists are very similar in terms of their structure. One of the big differences, though, if data frames are a collection of vectors, all those vectors have to be the same length, right? If my data frame has 102 observations, each column has to have 102 observations. Lists have no restrictions on that. The elements of a list can be anything of any type, which is, yeah, go ahead. So so a list can always be used in place of an anything. That being said, you usually only want to use lists kind of as last resort because they're so messy. And I'll show you what they look like, and you can see for yourself that they're useful in the. So this is what L1 looks like. It's a list of 4 W, X, Y, and Z. And the first element was a vector, the second element was a vector, third was a vector, fourth was a vector. L2, I made it out of first, second, third, and fourth, but then I added a 5th element that is a data set. And if we look at it, what we see is that first, second, third, and fourth are vectors, and then the 5th element is just a data frame. So it's very much just a bag of stuff. And because it has this unguided structure, they can sometimes be really frustrating to work with because it's hard to iterate over them. If you think you're going to get 15 data sets, then the 16th one is just a string saying, sorry, no data. So they can be tricky to work with that way. That being said, a lot of functions will return them because they're never the wrong structure for something. So the applied functions, tapply is the one I use the most often, returns lists in part because data frames require that every column have the same number of observations, and lists don't have that restriction. So I don't often choose to work with lists, but I often get lists returned by other functions. So it's helpful to know how they work, but I don't create them all that often. Unless, like I said, the one example is there have been times where I've had to build a bunch of different regression models. So rather than trying to name like 25 different regression models, I put them in a list, and then they're just the first, the second, the third, all the way through. All right, so that's a little later than I wanted, but we were slow starting and had a battery issue. And so on the course website, there's a section called R code, and there's that S1.01. S1.01-basics. The naming convention makes sense. It might be SO1.01. So take a look at that. I think it's all the code we've run today, right? Yeah. So take some time. That's all the code I've run in my example slides so far. Make sure you can run that. Make sure it all works, that you kind of understand. Go ahead. Oh, weird. Sorry. Yeah, sure. Wonder where that went. One of these must have applied to the. Did you get this email? You see your email there? What's your name? I don't see it there. Weird. Wonder how I missed it for somebody. Sorry. That's fine. I don't want to reply. That's not the right button. Yeah. So yeah, take a second, run that SO1.01. I'm gonna get water, and I'll come back and just make sure everyone's able to do it, and then we'll move on to more data set stuff. I'll leave this here just in case walking out costs it. So a few little hints when you're working in RStudio. Control Enter will run the line you're currently on, or if you have a bunch of lines selected, it'll run what you have selected. That's an easy way to run whatever you're working on in the code system. When you're in the in RStudio, Control-1 moves you to the source file, and Control-2 moves you to the console. So if you want to flick back and forth between them and don't want to use your mouse, Control-1 and Control-2. You said that confidently. Let me make sure that, yeah. So yeah, it's like when I'm running these commands, if I press Control-Enter, it just runs the command I'm on. If I select a bunch of things, it runs them. Now, it's not like Stata. Stata has this really weird and kind of useful, like if you select one character in Stata and press Control-D, it'll run that entire line. If you do that in R, it just runs the letter you have selected. So in R, it'll only run what you have selected, but there's a button to run things line by line in R, so it gets that trade-off. Although it is kind of nice in Stata to be able to do like Shift up to select like parts of 2 lines and run both lines. It's a weird programming decision, but teach their own. Plug my laptop in. 3 hours is a long time. Uh-oh. I did that already. All right, so how's it going online? Was everyone able to get that script downloaded and run? Great. If you want to take a little standing break or go to the washroom or anything, feel free to as well. Might as well ask now. Does anyone have any specific needs of R? Like, are you learning R? Has anyone assigned it to you for need to use it for your thesis or any specific uses, or just something you wanted to learn? Okay. Yeah, it's something we've debated as a department for a while. I actually thought so. I just came back from a year off parental leave. I thought you guys were gonna be the first group. Are you all finishing your first year? Well, not you. I thought the first years would be the ones that I thought they would be the first ones to learn R. I thought we were going to make that switch. But I don't teach any courses in the master's program, so I'm less connected to it than I used to be. I used to teach the intro biostats class before Cindy and Sonia got hired. But they're actual biostatisticians, so they make more sense as the people to teach it. But yeah, R and Python, you'll find a lot more. I'm actually considering switching my class to Python because I teach a biostats class for computer science students. So I'd rather not. I think R is better at what we do than Python is, but Python is better at machine learning. Python can also run everything in R, so like it's a more powerful tool in that way, but it doesn't have an RStudio like Jupyter Notebooks or some of the other environments people program in Python. They're fine, they're nice, but they're not as nice as RStudio, so I like to stay in that environment. But yeah, Python's a useful skill because that's where all the machine learning is, and like all the AI development you see would be done in almost exclusively in Python. All right, well, if there are no questions, we can move on to data sets. Script console, file management. So I talked about some of the buttons. I talked about the pane layout earlier. Script versus console. This is something that I try and communicate a lot if you're coming with no analytic experience, what to put in your .r file versus what to just type in the console. And one of the mistakes I've made before is telling people to do everything in their .r file, and people take that very literally. Don't do everything in your .r file. Don't be scared to run things in the console. That being said, like you've worked with .do files or .sas files, I guess in SAS you don't have a choice, right? There's no like command line to type things in SAS. You have to run them from the .sas file. But in Stata, like there are sometimes like you might run just a tabulate command in the console. Just you want to see a 2x2 table. You don't need to save it. But that being said, most of the stuff you're typing in your .do file. And the R is the same way. Anything you want to save, certainly. But even if you're typing something, I often find if I'm doing a lot of string matching, even though I'm not planning to save it, I'll run it in the .r file because I think I'm going to do it wrong the first time. And if you do it wrong the first time, it's easier to correct your typos and rerun it from the script than trying to. Now, when you're in the console, two useful commands. If you just press up, that'll cycle through what you've run previously. Stata does this as well, but Stata doesn't do it if you ran something from your .do file. Like if you use the Control-D command in Stata, it doesn't give you that option. It gives you a weird. Just try it sometimes. It's weird. The other thing you can do with that, if you press Control-R, you can actually search through the commands you've run recently. So like, let's say you've been running a bunch of stuff and you want to rerun a tabulate command you know you ran before. You press Control-R and then just type what you did before. So let's say I want to see what I did with prov before. That gives me all the commands I've run so far that had the word prov in them. I find it helpful, yeah, if there are commands I'm running in the console that I need to keep rerunning, and for some reason I don't want to save them in my .r file. Pane layout we talked about. File structure. Oh, yeah, one more thing I should talk about. Where are looks for files? This is actually important for what we're talking about next. We're going to talk about file structure. See up here, you've got a // I've got / teaching R4HDS. I've got a file directory. You might just have // that is where R is going to look for files, right? So you can when you reference files, you can reference them from the root, right? So C:/ for Windows users, or just the base / from the base directory for Mac users. But it will also start from your working directory, and this little string up here at the top is what R considers your working directory, and you can change that. So mine's gonna be a little different because I have an active project. We're not going to talk about projects right now, but if you go to, I know it's Alt-SW for, I'm going to see what that is. So Alt, if you go to Session, Set Working Directory, you won't have that first option. You won't have to project directory. Your first option will probably say to source file location. Is that right? If you click on that, if you click on to source file location, that will set your working directory to where your R script is currently saved. So when you set your working directory to source file location, it will set your working directory, the starting place it's looking for things, to where your R script is. That's really useful because as you're working on a lot of analytic projects, your R script is usually saved with your data frame. So if I save my R script next to my data frame, when I'm reading it in, I don't need to reference it from like C:/ user / samps / documents / blah, blah, blah. I have a very deep nested file structure. Instead, you could just reference it I can just reference the CSV file I'm reading, and the first place it'll check is from my working directory. So I often find when I open up R and I open a new R script, I'll press Alt-SW, enter. And that is the key. That's the series of key commands to set your working directory. Also, if RStudio isn't open and you double click an R script, it opens RStudio and sets the working directory to the directory you just opened it from. So all that being said, when you go to read, which is what we're going to talk about next, when you go to read a data set to import a data set, and you get an error, like a file not found error, especially if it's a script you've worked on before, the mistake is almost always that your working directory wasn't set. Like you didn't set your working directory to what you meant to. So just check to make sure your working directory is where you thought it was, and then correct the location. So this is the way I envision the analytic process and a useful way to think about it for R. This idea of bringing the data in, cleaning it, analyzing it, and producing results. Getting data cleaning completely done before analysis is really important. We'll talk later about RMD files where we talk about functional reporting and integrating analysis and reporting in a single document. But when I'm doing that kind of structure, one of the useful things about those files is we have these code chunks. And my first chunk is almost always setting the file up. My second one is reading the data in, and my third one is processing the data. And all the data manipulation. This is one of the things that's really nice about R having multiple data sets, is all of the data manipulation I do is before I do any analysis. So even if, in reality, the way I write it is I would, process the data the first time, do some analysis. If I realize I need to switch the data into long format, I'll do that. But I'll go back up to my data processing step and do it at the top. Do all your data processing before you do any of your analysis so that the data is consistent throughout the script. It's a really useful, even if, I didn't draw it. There are sometimes you'll have some back arrows, right? You get into your analysis and you realize that a variable wasn't created. That's okay, but go back to where the data cleaning is to create your BMI variable, or go back to your data cleaning step to fix your factor variable. It's good to separate that data cleaning from analysis, because if you can do all your data cleaning before all your analysis and get into that habit, your analysis script will be consistent. It's useful if, when you come back to a project in a month, you can run either one .r file or two .r files. Sometimes if your data importing and cleaning is really complicated or slow, you might decide to do that as its own script and then do another. I've been doing that recently with the meta-analysis I'm doing with Jill. I've been doing the data processing in a separate file, but that's just because I'm actually doing it in a bunch of different files, just because I was several hundred lines deep in an R script and getting annoyed about having to click around too much. So I just split them out into their own scripts. But regardless, that's the difference. And this is a good process to think of, even if you're not in R, right? If you're in Stata, this is also a good way to think of it. There will be, as we talked about, there will be some data cleaning you have to integrate into the analysis if you need to do data transformations, right? If your regression models require you to switch the data into long format, but you still want to do like your table 1 and your table 2 and your basic summaries in wide format, then you obviously can't do all the data processing at the beginning. But still, this idea of that you build your data set, clean it all up, do your analysis. The other thing about R is R doesn't produce any results on its own, but it gives you more power to generate those results in a usable way. So one of the frustrating things I'm sure you've found, copy to HTML or copy to like the fancy copies they have in Stata are more useful than plain text. They're still kind of annoying, and they still don't always work. And there's nothing more frustrating when you're working with Stata you've done all the work to get your regression models out to file, and then your thesis committee tells you need to manipulate your data in some way, right? You didn't filter out, you missed this ICD code, so you accidentally kept in 45 subjects you weren't supposed to. You have to rerun everything. And then you rerun everything. None of your conclusions are different, but all your numbers are different, and you have to do a bunch more of that really annoying copying. Having control over it, it would be nice that if I could go to my data cleaning step, pull out those 45 subjects I wasn't supposed to, rerun my analysis, and produce those tables through my statistical language so that I don't have to copy and paste. I find that I rarely copy anything with my mouse, right? Everything is being produced analytically by the program. Now, ultimately, there are functions to write tables directly to .doc files in R. Good luck if you want to try that. I have not found it super satisfying. Like as much as I love all the output, and we'll see some pretty output in R, ultimately we do our final production in Word in our lives. And it's just, there's no way I've found to produce a table that will cleanly go. Like you're always gonna have to do a little bit of formatting, but it's just right at the end. So there's an advantage to that, separating the results from the analysis and getting controlling the results output makes it really easy to update the results, but it puts a little bit more onus on you in terms of how to produce those results. Reading your data. So these slides are available on the course website. I'd suggest pulling them only because I've linked to a couple of tutorials that I've cribbed these examples from. So this data camp tutorial has a lot of good examples of functions for reading data in. You can read in almost any data type. I've never run into a data type other than some kind of vague proprietary ones that R can't manage. That being said, you're mostly going to deal with CSVs, right? Comma separated, like fake Excel files, or real Excel files. Actually, we're getting to the point where I probably use Excel files as much as I use CSV. XLSX files are really easy to read in and read out. So read.csv is the one you'll use the most often. There's a data directory in the course website. Pull all those data sets because I've got a bunch of dummy data sets that we'll use for lectures there. I would encourage you, I think I said this in an email, but if you have your own research data sets, feel free to bring those as well and work with those. You're welcome to kind of work on the cleaning of those rather than cleaning up dummy data sets if you want. But if you don't have one, or if you're working on a thesis project or a project that has kind of secure data, then you don't have to. You're welcome to work with ours. So this is what I was talking about. When you read a CSV file in, you can reference directly from C. You can pull locally. So in this case, I have a data directory right next to my .r script. So rather than reading from the base, I can just read from that data directory. You can also pull from the website. So if you do raw.github user content, you can pull directly from any website as long as there's a CSV file there. You can pull from the web, so you don't actually have to download these data sets. If you want to use this URL referencing, that's the directory for the Framingham data. Other data types, there's a read Excel function in the read XL library. Haven is an excellent library for reading just random. You might see there used to be still is. There's a library called Foreign that used to be really good for reading data sets, but Haven has just started doing it better. I don't know if it's better maintained, but read SAV for SPSS data and read DTA for Stata data I've been using a lot recently, and they're very smooth. SAS data sets can be read in using SAS7BDAT. Now that assumes that you have your SAS data on a file. So like at HDNS, I don't entirely understand where our data is because it leverages the SAS library system, and this isn't great. We don't have a great system. That's why at HDNS we're going through this big process of getting R connected to the data, because R can't access the SAS data library infrastructure. But any format you have data in. Do you have a question? Very good. Yes. So I actually, with this project I've been doing with Jill, 19 different projects. Each one has their own directory. I'm so excited when I open it up and it's an SPSS or a Stata file, because it maintains formatting really well, to the point that I haven't found a mistake yet. So as far as I can see, I shouldn't say never, right? There might be certain areas where it gets it wrong. And there are some weird things you have to do with read. There's one command you have to run, and I can show you. There's an as factor. When R reads it in, it doesn't apply the factor levels correctly unless you run this one command. So you have to run a custom function from Haven to get it to apply them, but it's never broken for me. And at the end, I end up with really clean detail. So like when you look at my command to read in the Excel files, they're like 80 lines long. The DTA one is 7. Like it's read DTA, fix the index command, maybe create one variable, and then it's good to go. No, it's really good about reading SPSS and Stata data as well. It used to be really good about reading SAS data. It's been so long since someone has sent me a SAS7BDAT data set that I assume it's still good at it, but I just haven't had experience enough recently. And I guess I should talk about the idea of libraries, because I mentioned things like ReadXL and Haven. There are over, what I say, 10, 13,000. I haven't checked that number yet. It's not worth counting them because most of them are bad, but they're also the best things you'll find. So how you download them? You can either you type install.packages and the name of the library in quotes. You only have to do that once. That's what pulls it from the web and installs it in a custom location on your machine. And then when you want to load it, you load it with the library command. So if you I didn't load any libraries. All right. So in the third section, we'll use a library called tidyverse. And that just loads a bunch of custom functions. Tidyverse is actually an interesting library because tidyverse it's not a library, it's like a meta library where it actually loads a bunch of other libraries. So loading tidyverse is akin to loading ggplot2, tibble, tidyr, reader, per, dplyr, stringer, and forecast. So it loads 8 libraries itself. Note that I call them library and the function calls them library, but CRAN now calls them packages. So you'll see those two terms used interchangeably. So you see I had the library command on tidyverse that attached 8 packages, but it means the same thing. So you'll use a lot of libraries. This is one of those places that like don't save your install.packages in your R script, because every time you run install.packages, R will try to reinstall it. And tidyverse is a big library. So if your R script every time is trying to download and install tidyverse, it's going to be super slow for no reason. So the install thing you only have to do once. One thing you'll also notice is, and it's not consistent enough for me to see if I can library, fake library. Do it. Ugh, I can't figure out how to trick it. But there are times when you try and load a library in the code file, if you don't have it installed, you'll get a very tiny pop-up here at the top that says, you don't have this library, would you like to install it? And if you click install, it actually runs it not in the console, but in the background jobs. So it still downloads and installs it, but doesn't steal your console when you do it. But as you can see, I don't entirely know how to trigger it. Sometimes it's there, sometimes it's not. But if you see it, use it, because it's a way to get it. It will quickly install all the libraries. And there will certainly be some times where if you're downloading other people's scripts, you might not have like several of the libraries they have. But the more you do this, the less it comes up. Like I don't install libraries very often anymore because I've kind of installed all the ones people use. There are also ways, so all of these are downloading from CRAN, the Comprehensive R Archival Network. And that's the people that run R. The R project people are the ones that maintain that. But you can also install R libraries from like unverified, makes them sound kind of risky, but kind of more cutting edge beta versions of libraries directly from GitHub. And I won't show, but most GitHub libraries will have commands for you to install their library, but you don't have to install from CRAN. It's just by far the easiest. So how to reference libraries. Obviously, if you load a library, it loads all the functions from that library into your workspace. So then you can, so there's a function in the psych library called describe. And if I load the library, I can do the describe function. I can also, if for some reason I don't want to load the entire library, I can do the name of the library, 2 colons, and the name of the function. Now, there's not a lot of reason to not want to load a library, except there's no guarantee that the functions in the library are unique, right? So psych has a function called describe. Describe's a very common word. HMIS is another, Frank Harrell's miscellaneous library, is a library I really like. It also has a function called describe. So when you load a function, when you load a library, it will overwrite the previous version. So like whatever library you've loaded most recently will give you that version. But it's kind of hard to get the distinction. So you'll often see people doing this double colon referencing. You'll find it online a lot for functions that have kind of generic names because the authors didn't make sure that describe was a unique function. And it's hard. Like I don't know of a way to search all 13,000 libraries to make sure that when I'm writing a library, it's like, has anyone taken this yet? So we just do that double referencing. So I will do that sometimes. We'll see it later. There's one tidyverse function that gets confused with one of the functions from the library you do mixed effects models from. Like there's one collision I run into a lot that I find really annoying. But other than that, you don't see it that often. The other place you'll see me do it is this example. And this is what I was talking about. Remember I said the ANOVA with a lowercase a is wrong. It gives you the wrong sum of squares for, I think wrong. They don't think wrong. They just think not the most common. Like it's type 1 versus type 3 if you're in SAS. So because of that, I use the capital A ANOVA from car. And I tend to write car 2 semicolons ANOVA just to force myself to make sure I'm using the right function. Because if you use the wrong one, there's nothing really obvious at first that you've made a mistake. And then that mistake would just propagate through. So that's one place where I almost always write car 2 colons ANOVA just to force myself to not accidentally call the wrong function. Even though they do have different names, because capital letters matter in R, like ANOVA with a capital A and ANOVA with a lowercase a are different functions. Is that true in Stata? Is that true in SAS? Not one of them. Is SAS capital sensitive? Yeah, SAS is the one that's not capital sensitive. You can put capitals wherever you want. And red cap is another place where it throws me off because I program a lot in camel case, and if the uppercase letters don't have any difference from the lowercase letters, then when it converts it, my variable names now look really terrible because they're just one lowercase word mushed together, and then you can't read it. It's hard to go back. So data cleaning, often the longest and most arduous part of the analysis, definitely the least fun. Whether it's the longest or not depends on how complex your analysis is. It's really hard to come up with a guide to data cleaning. I'll go over some of the basic steps, but it is very project specific. Some of the questions you will always ask yourself are numbers formatted correctly? Are missing values handled correctly? And then these ones often mess up these ones. Are factor variables formatted correctly, both in terms of all the factor levels are there, there are no spurious factor levels, and you've got the right reference level. Data cleaning is also where you're going to generate variables. So if you've got like the components of the SF36 survey, you need to convert it to a quality of life score, or you've got height and weight, you need to calculate BMI. That kind of stuff you should do in the data cleaning step before you start your analysis. So in terms of cleaning your data, it's often an iterative process where you read it in the first time. If it doesn't throw any really obvious errors, you kind of want to run just a preliminary data summary. Codebook is a great example. I think that's the codebook comment detail is my favorite. As long as you don't have, if you got a lot of variables, that's not the best function to use. But in general, that's a great function to quickly look at every variable and make sure see where the mistakes are. And these are kind of organized in terms of increasing levels of detail and size. So STR is a really good way to that's kind of the, I guess, desk, and the one that just gives you like the variable and its type and a label if it's there. Like it doesn't give you a lot of summary of the variable, but it tells you what it was read in as. As I said, the describe function from the psych library is the best quick summary, but it's only really a good summary for numeric variables. It doesn't give you a good summary for categorical variables. Frank Harrell's HMIS is Frank Harrell's miscellaneous functions, just a collection of random stuff that's really useful. His describe function is really good. It's a nice mix of brevity but detail. It's long, but it gives you a decent numeric summary, a decent summary of both categorical and continuous variables. This DF summary from the Summary Tools library, I've just discovered this, so I don't know all the details of it yet, but I really like what it produces. Here, I'll show you one of them. Oh, you know what? This is a network data set. Why do OneDrive and SharePoint not know how to integrate with Windows File Explorer better? Like Microsoft makes all of it. How do they get so confused with how they? Anyway, it's the worst. Oh, that opened. So this is what a DF summary looks like. There. So you can see it gives it really. Here we go. Here's a little easier one. So for every variable, it gives the type. Gives for dates, it gives some ranges. It'll give you a little bar plot, summary of distinct values, summary of missing values. So it's a really good kind of complete summary of every variable. It's visual, so you have to export it to the viewer. It doesn't work right in console. It is long, like it's taking up a lot of space. So when you run this on a variable of 200, a data set of 200 or 400 variables, it's going to create a lot. But it's a great. I don't often use it as the first summary of the variables, but I will often use it as the last summary of the variables. Like I'll check the DF summary before I get into my analytics, because that's where I can check to make my last check to make sure that I haven't. And some of the things you're checking, like, does 0 make sense for missing, right? Am I getting all missing? Am I getting way too many missings? For numeric values, it helps me check the minimum and the maximum, and that's where the histogram is really useful, right? The histogram, if you're seeing big spikes in places you didn't expect, or you're seeing like negative numbers here, it's a quick summary of that. The HMIS library is similar in that sense. DF summary can also be a little bit finickier. It's the one that fails more than the others, or gives you weird results more than the others, but it's not terrible. So what do we do when we find mistakes? We want to make sure our variables are correct. We want to convert numbers to numeric, strings to characters, make sure factors are correct. First, characters to factors. So R's default value when it's reading in a data frame thinks everything's numbers. When it encounters a non-number, it switches to character. Some functions will then convert that character to a factor. And one thing you might have noticed in my read.csv command, I had strings as factors equals false. So the read.csv will, after it's found a character vector, will convert it to a factor. I tend to not want to do that, because if that column was supposed to be a number, it's a lot easier to convert a character to a number than a factor to a number. So I like to leave my non-numeric columns as characters, and then I will handle the converting it to a factor, just because I think that gives you a little more control at the beginning and avoids some mistakes with your numeric variables. And the biggest culprit here is often missing values. So you can see that read.csv, there's an argument na.strings. I think Stata's default missing value is a dot. I think when you export Stata data to CSV and then read in a CSV, Stata export it with a dot as the missing. If you read it directly with the read.dta function, it should get the missings correctly. But if you're exporting to a CSV and then importing a CSV, dot is what they use. I don't know what SAS uses for a missing value, because SAS is a bit like SPSS. It has complex missing values. It has classes of missing values. No one uses them, but it has them. And it often uses negative numbers, I think, for missing values. But regardless, you want to make sure that you're not getting the missing values confused. But you can tell by default, it will only R will only consider blanks, like completely blank fields, as missing, but you can tell it what the missing values are, and it will look for that. So for example, when you write an R data set to a CSV file, if you use write.csv, it puts capital N, capital A in all the missings. So then when you read that back in, you need to tell R that it's using NA as the missing values. I talked about the factor function before, but I didn't talk exactly about its arguments. So let's say sex is a character value with M's and F's for male and female. No, actually, in this case, sex was a numeric. So the Framingham data that I have, and I use the Framingham data a lot for my examples, just because it was the demo data set in the first textbook I used, so I just get used to using it. It has males and females coded as 1 and 2. So I'm creating a factor variable from the sex column of the data set. It has levels 1 and 2. I'm going to label 1 as male and 2 as female. So that's how that works, where the levels are what it's coded as, and the labels are what those levels represent. Often your levels will equal your labels, and if that's the case, you don't need a labels argument. But if you want to relabel things, you can do it that way. We'll just skip over the cut function. Cut is if you want to convert a variable, numeric variable into categories, and you can kind of intuit how it works there. Because I want to get onto the script for this section. So we're going to move on to SO1.02 is a chance to play with reading some data sets in. So pull that one down. It'll read the Framingham data, I think, as well. But there's a data set called Telcom that I want you to try and read in and clean, and then as a group we'll get it organized. So I want you to read it into R, check the variable types, make sure they're correct. So work in groups for a couple of minutes, and then we'll talk about it. And to the group online, you three can work together. You're actually a good sized group. Oh, Eric's taking Finley's. No one else is taking Finley McGuire's data science class this summer, are they? I know that he's using R, so I'll pull up that script. SO1.02. Oh, you didn't have psych? Oh, did you get the pop-up? Nice. So why didn't it work when I tried it? Maybe because the library I referenced wasn't real. So yeah, so if you look on the GitHub page, there's a data folder, and you need to download those ones. So I don't know if there's a download all button. But I think particularly, we'll use most of those today, actually. Yeah, and then the way that I have that script set up, you can see that it's looking for a directory called data, and then a data set in there. So it's expecting your working directory to have a folder called data. So you could either change that reference or put the data set in a data directory where it's looking for it. Yeah, so often what I would suggest, if you look at my file structure, oh no. I've got mine set up slightly differently. So like my working directory isn't where my R scripts are. I set my working directory as the base for the entire course. So this is where my working directory is, even though my scripts, and the reason I do this is because my scripts might be in lectures and they might be in R code. So it's not really consistent. So I make this, and then there's my data file. So I would just reference, I'm referencing everything from there. I would say that most of my, there are these concepts called projects in RStudio that I've started using more and more for big coding projects. So this is a project. Projects are also, RStudio has really good tools for pushing and pulling from GitHub for projects. So like the easiest way for me to put stuff to the course website through a project. When I'm using projects, the working directory is where the project file is stored. So you can see here, there's something called a .rproj. But if I'm just working with R scripts, then as soon as I open R, I'll do that Alt-SW to set my working directory to where my script is. And then I reference all my data sets relative to that. I've found I've gotten in trouble too much using like referencing from C:, because my file structure is changing too often. Now it's not the end of the world, right? If you run a script and it doesn't find the data set, you just have to re-reference, change part of a string at the top of your file. It's not going to be a huge difference, but I do find that I make doing file referencing from the location of the script is the way that I find I make the fewest mistakes. It's the equivalent of what is it in Stata? Set WD? Is that how you change your working directory in Stata? I can't remember. Yeah, so you've got a dat object and a Framingham object. So you've got both. And actually I'll use the actual import functions. I've never used them. What do they look like? Oh, there's an import function in the environment command? Huh. So how's that work? So an environment. Oh, import data set. Neat. Yeah, so I mean, that's fine for now. I would caution against doing that because it doesn't give you the command to rerun it, right? So next time you open R, that data set won't be there, where I can always open R and rerun this and then have it available. Unless. Yeah. And actually, you know what? If you want to do it that way, that's not a bad way to do it. Do you see what it did here? It wrote the import command for you. So if you want to use that import function, then a good way to do it would be to use it. And then you can make the manipulations in the interface. But when you're done, copy this command into your .r file so you can reproduce it for next time. So what that means is missing values were caused by the conversion of variables. So did you get that from an as.numeric command, or does it?
Yeah.
Yeah. So almost always what's that? So actually we just, that telecom data set was just up. So you can see that this column, total charges, if you run as.numeric on that, for the second row, fifth row, and eighth row, those aren't numbers. So when it tries to convert those strings to numbers, it's going to, that conversion of character to numeric is called coercion. We're coercing a character to a number. And we created 3 missing values where there weren't missing values before. Now we know there were missing values. They were supposed to be missing, but it warned you about that because you told it to convert this vector to a number, and it's just saying some of the values of this vector are now missing when they weren't missing before. And it's often worth comparing the before to the after. Now, if you know that it's all dots and NAs, but it's worth comparing because sometimes you might get people like someone might have in a height variable, they might have said like 185 or 186 centimeters, right? They might have said 6'2" or 6'3", and that or is going to throw off because if I tell R convert the sentence 185 or 186 to numeric, it's not going to give me 185.5. It's going to give me NA because that's not a number; it's a sentence. So it's you often run that command and kind of expect that warning. But if you don't, if you thought it would convert cleanly and you get that warning, it's worth going back and checking which of these values was missing. Yeah, good question. So we get 2 things. We can get warnings, we can get errors. A warning happens when the function finishes and produces what it's supposed to, but there could have been some problems. And the problems can range from things we expected to complete shutdown, right? So trying to think, so there's some regression situations. Sometimes we get a warning if there were convergence issues, and then the model will finish. It will give you coefficients, but it'll warn you this model didn't converge, and the coefficients are garbage, right? Other times you'll get a warning because of some, often I ignore warnings. Often it's things like this, data conversion issues, but that's different from an error. If you run a command and you get an error, the resulting object will not be created. So an error happens when what you ran can't work. A warning tends to happen when what you ran can work, but there were some unexpected results as well. You'll get a lot of warnings. You'll actually get, there'll be some situations where when you finish a command, you'll get a little prompt that says there were 325 warnings, type warn, open bracket, close bracket, to see the first 50 or last 50. I can't remember what it says. That often happens in data processing. And I find it happens with we'll see later, the tidyverse commands. There'll be something like expected a date got a character, or expected a this got a that. So they're some of the functions, particularly the data processing functions, might throw hundreds of warnings because like there's a problem with one column, but it happened 400 times of your 1,000 subjects, so that gives you 400 warnings. So warnings, you can get a lot of warnings sometimes, but we don't always react to them, but you should acknowledge them and should look at them to make sure, like, how serious was this? Was this a little warning or a big warning? Errors, obviously, errors we have to deal with because that fully breaks our command.
Everything was perfect? Like, will it fit anyway?
Yeah.
If
It's
it was
fun.
perfect, would it also give these warnings?
No.
Okay.
No non-missing arguments to
Yeah.
Mac. Turning it, no non-missing arguments to Mac. Missing argument. Huh, it's a funny warning. That's from the Framingham command?
No.
Okay. Do what you did.
Like, I read the code and then I rewrote. I tried rerunning this and then just output as before.
Yeah, so it's what you've referenced. So you created a variable called BMI cat within DAT. So now you need to run the table command on DAT $BMI cat. Yeah, because the idea is that you have a data set. No, you need to pull off the $sex. Yeah. So you just created a. Yeah, there you go. So if you look at this is sometimes that. See, this is your data set, and you create the last one is the one you created. So that's the new variable you created from that one. So there's the original BMI variable. Sex is the first one, and then there's the one you created. So if you want to do a table on that, do dat $, the name of the variable. And you can do that. You can do dat $, for any of the variables if you want to create any of those tables. Oops. So there's actually there's some guest access right there. So is everyone able to get the telecom data in? You can kind of save it wherever you want. And I just used read.csv. We'll talk later about at the next our third section today is about the tidyverse and a library called dplyr. It has a read underscore CSV. I also like that one, but read.csv is the base one. That's fine. So this is the data set itself. And the first thing you do when you get a data set like this, we can look at the str of it. So str is that's similar to, I always forget the name of this command instead of desc. Maybe. Let's just list all your variables and the type. Codebook gives you more details than that, doesn't it? Or maybe if you run Codebook without the detail, it just gives you the variable names. Yeah, just one line per variable. Is that Codebook? I don't know. This is exactly what we're doing right now is the exact process I would go through when I'm in Stata every time trying to figure out what the command is. But it shows us one of the useful things here. I mean, it's kind of ugly, but it shows us the character types. So the first thing we want to figure out for the character types is whether they all match what we want. So custom ID being a character looks right? It's a mix of numbers and letters. There's no real reason to make it a factor because it's unique for every subject. So character's fine. Monthly charges seemed like it read in cleanly as a number, but total charges should probably be a number, and then payment method and churn should probably be factors. So my first step would be to address those three issues. So I would total charge. Oh, this was the one that Laura mentioned, where if we convert this to total charges, if we use the as.numeric, so it was a character, I just want to turn it into a number, we get this warning, NA is induced by coercion. And what's happening there is if we scroll up here, these values, n/a, NA, it looked like it got that one correctly, but R didn't recognize those as missing values. It thought they were characters, so that's why it read the entire vector as a character. I want to convert it to, and it's just warning me that these I converted to missing. The next one had to deal with payment method. It's a little trickier because we've got what looks like 3 missing values that weren't coded correctly, and then 3 or 4 factor levels. So what I would probably do is I would create a factor variable with the levels I want, and then everything that's not included in my listed levels would be deleted. So I'll also, I haven't done this yet, but we'll see it a lot in the next section. Method. Telecom. Equal. So white space doesn't mean a lot in R. So in this example, I'm going to have one line per, we'll see this a lot more in the tidyverse section, but I'm going to have one line per, oops. Sorry, which one? Oh. Oh, the stuff I'll break up. No, I'm just typing that now. Yeah. Yeah, so what I'm doing here is I'm creating a new factor variable with just the levels I want, and everything that isn't listed there will be made missing. So if I run this, crossed his fingers, oops. So I just did a table of that variable I created, and there's an argument within table that says use NA, and you can either set that to if any, so it'll include missing values in your table if they exist, or you can set it to always, where it will include a missing level even if there are no missing values. So you can see that if I were to do this for customer ID, if I do a table of the customer IDs and leave use NA equals always, it gives me an NA level and just says there are none. So you'll find yourself, if you're using the table function to inspect your data cleaning, you'll want the use NA argument a lot, because a lot of data cleaning is keeping track of your missing values. And that's about it. You can also factorize the churn variable if you want. Then the final thing I would do before I moved on is just look at some summaries of all the variables just to make sure that they're all making sense. You can, it's a failing on my part. I have a chronic problem of calling all my data sets DAT, to the point that like calling this dat.telecom, my fingers keep messing it up. All of my data sets are called DAT. And the only time they're not called DAT is if I have a second data set. So my base data set is called DAT. That's just a tick that I got used to. I wouldn't call them data, only because there's a function called data, and there's no problem. You can have variables called things that functions are called. It doesn't break anything, but there's a chance you get confused, right? The autocomplete might get confused. It might pull up the function rather than the data set. So because of that, I started calling them all DAT instead of data, and it just stuck, and I've been doing it for 20 years. Yeah, so you can see, yeah, you can, so like you can here you can see I called it dat.telecom, but or here I called them D1 and D2. You can call them whatever you want, but just I get in that habit of calling my data sets DAT or DAT01 or DAT02. I would actually recommend, if you can force yourself into the habit, descriptive names. Like this should be called, that first one should be called dat.fram, even if it's the only data set. But if you're only working with one data set, it's probably okay to call it DAT. You'll remember what it is. Any other questions there? Yes. Yeah, there's a read underscore DTA function from the Haven library, and it gets data in really quickly. So if you're doing a lot of analytics there, and we'll talk about graphs, I think next lecture. I have to go back. I've been waffling a lot, in part because of what I'm going to tell you now. So the tidyverse. This is a set of libraries developed by Hadley Wickham and the people at Posit. So Posit is what makes RStudio. Hadley Wickham is the chief scientific officer at Posit. He probably has a new title now, but he has a number of great libraries, but nothing greater than the tidyverse. So the tidyverse is a collection of libraries. The two most important are dplyr or dplyr, and ggplot2. So ggplot2 is the graphing library that we'll talk about later. The tidyverse, they created this concept of a pipe, and because of that, they introduced a new way to a kind of a new grammar for writing in R. So it's all the same, but it looks fairly different, and it's a little bit more readable, and well, it's a lot more readable. That's why people like it. We'll borrow heavily. Wickham and his colleagues wrote a textbook called R for Data Science, and you can imagine where I came up with the title for this course. It's because it's cribbed so much from Dr. Wickham's work in R for Data Science. It's the best. It's probably the best R textbook out there. So like, if you want something to read like a chapter book to read for data science. It's all available online. You can order a printed version for a pretty low price if you want, but it's kind of designed to be an online textbook, like it's hyper-refed and it's really well linked. It's got lots of good code examples you can copy directly into your commands. So I would recommend that textbook. I'm also going to, this is the last slide I'm going to have. I'm going to switch to Markdown files because they have better incorporation. There's just a lot of code and the code doesn't copy well into these. So I'm going to switch to these. So dplyr pipes and data transformations. This can be confusing, the idea of pipes, because it's kind of changing the way we think about how functions are structured in R. But if you can wrap your head around it, it lets you do a lot of really powerful stuff in a much cleaner structure. One of the problems with R is just, so this, you can see here, this thing at the top is kind of the default process for reading the Framingham data in, right? You read the Framingham data, then you clean the sex variable, the BMI, you create the BMI categories, and then relabel diabetes and hypertension. There are a couple other variables you might want to relabel. I've only done those 4 because that's what I'm going to be using, but I'm not going to stand here and argue that what I've written there is pretty. It's kind of ugly. The dollar signs are ugly. There's also there's this inherent confusion where I create a factor, I factorize this diabetes variable. What that does is it creates a new vector that is the factored version of diabetes, but it doesn't intuitively assign it to the data set. I have to do that manually. So in this case, I overwrote my original diabetes variable, but I could have just as easily created a variable called diabetes.factor or factor diabetes, whatever you want to call it, and have the 2 variables created side by side. So when I create a new variable in R, it doesn't intuitively get assigned to the data set. I have to make that decision. And in this case, you've seen for sex, diabetes, and hypertension, I created factor variables of those and overwrote them, where you could just as easily, like here, I didn't overwrite BMI with the BMI categories. I made it a separate variable. It's fine. This is a clean way to do it. It's just a little bit ugly and it's not super readable. Subsetting in terms of both rows and columns can be really unreadable in R. It's fine. It's just it can be confusing. So one of the key additions the tidyverse makes is this concept of pipes, to the point that the pipe I'm going to use, this the horizontal line with a, I guess, a less than sign or greater than sign, that's a native pipe. So that pipe is now available in base R. They added that a year and a half, 2 years ago, because Wickham and his colleagues' work with pipes was so popular that everyone was using it. So you might see, I've done it all with pipes. You might see, let me pull up this code. So you might see pipes like this with the vertical line and the greater than sign. You also might see them like this, percentage sign, greater than sign, percentage sign. They both work the same 99% of the time. This version with the percentage signs is how Wickham and his colleagues, that's how the original tidyverse pipe works, where the base pipe is the vertical. I like the base pipe. It's cleaner, it's one less character, and I think it looks a little nicer in text. So I just got used to using it. But regardless, whatever pipe, so in all my code, I'm going to use pipes like this. But when you're looking for help online, you're going to see a lot of people using the % less than % pipe. They work the same. It's just what people got used to using at the time. So the way pipes work is it takes an object on the left side of the pipe, passes it as the first argument in the right side of the pipe. So you can see that if I do a table between sex and hypertension, I get a 2x2 table comparing sex and hypertension. I could also take the sex vector, pipe it into a table with hypertension, and it would add sex as the first argument in this function. So these two things are doing the same There are two different ways to write the same argument. And this doesn't make a good sales case at all for pipes because it's not anything. It just seems like it's kind of filler. But this idea that on the back end, if I have x piped into a function, it does table of x and then all the other arguments that were already there. And we can nest it, right? So if I had x piped into f of y, piped into g of z, first thing it does is it adds x into f of x and y, and then pipes f of x and y into the first argument of g. And that kind of nested iterative piping is really useful. The reason it's really useful is Wickham and his colleagues, when they wrote the tidyverse, the first argument of all their functions is the data set. So when they have data set manipulating functions, the first argument is the data set and it produces a data set. So the idea is you take a data set, you run, let's say, a select statement on it. So you pull a bunch of variables. If I pipe a data set in, the first argument's a data set. Everything after that is the arguments for that function. It produces a data set. That data set can then be pumped into a mutate function where I'll create a bunch of variables. And that can be piped into a rename function where I change some variables. So the fact that all of the tidyverse functions, not all of them, but most of them, take a data set as the first argument. Go ahead. Yes. Yeah. And the reason that pipes are useful is because they're prettier than, it's a silly way to think of it. Yeah, because it lets me write this. I want to take my data set X. I want to apply function Y to it. And then once that's done, I want to apply function G to it. I could write it like this, f of X and Y, and then G on f of X and Y. But that sequential nesting of functions gets really ugly. I had every Friday morning during the week, I would save my ugliest R functions. I'd send them to my brother and ask him to figure out what they do, because they just get ridiculous, like 6 or 7 nests down. And the problem is when you're trying to read what something like this does, you have to read from the inside out. Where this, I get to read the way people read. And when you combine it with the way that the tidyverse has used vertical space, it makes your code way more readable because we're doing things in the order they're written rather than trying to find like the middle of the nesting and branching out. But yeah, that's exactly what it's doing. It's nesting functions within functions, but in a way that's more readable. The other thing we get to do is way fewer dollar signs. So we don't have to, because we're within a data set, rather than dat $sex equals factor dat $sex, I can just do sex equals factor sex, and I've saved 8 characters. But the dollar sign just makes code unreadable because it's not an intuitively, it's not a grammar we read. So I'm going to look at 3 of the dplyr functions: filter, select, and mutate. Basically, filter is used if we want to subset rows of our data set. Select is used if we want to subset columns of our data set. Mutate is used if we want to create new variables. All of the functions, tidyverse calls them verbs. So tidyverse refers to these as verbs. All of them take a data set as their first argument, and then they'll take other arguments for the function depending on what you're doing. The other major difference is that we're not working with data frames. They are data frames. They're just not called data frames. They're called tibbles. Way more fun to say. And they are very slightly more convenient than data frames for some entirely kind of user experience reasons. So what they do, they print a restricted number of rows and columns. So if I oops. For example, if I run this command, and then I try and print, so if I try and print the Framingham data, I get this. It prints 25 rows, all the columns, like it's fine. It's just a lot. It's pretty overwhelming. If I instead use the read underscore CSV, this is the tidyverse version of read CSV. The only, oh, fine. You know what? I'm just gonna. If I do a Tibble version of that same data set, it prints it in a much more readable format, so it doesn't do more columns and can fit on a single slide. And you can see it's got little subscripts. So this variable, it couldn't fit the name, so it's, oh, it didn't fit it all in. But it also tells me all the variables that are missing. So just a more readable way to print the data. Yeah, go ahead. Yes. So I think it is. Oops. Print in equals 50. You said conf. Yeah. There's a print function that'll print out more. No, Tibble is one of those. When you load so actually, yeah, everyone load the tidyverse library. You probably won't have it, so then you'll have to install it. You should do that now because it's a big library. But Tibble is one of the eight libraries that makes up the tidyverse. Some other things that are useful. It doesn't partially match variable names. It's one of the weird things about R is if you've got a variable called cursmoke in a data frame and you type dat $CURS, if there's only one variable that starts CURS, it'll get you that variable. That sounds convenient. In reality, it causes you to make mistakes. So it doesn't partially match variable names. It's better with variable types. It's a little better about reading in variable types as you want. It's a little better about getting. Now, anyone who's had to work with dates before knows how frustrating dates and date times can be. But Tibble and the tidyverse functions for reading dates are better than the base ones, so you're more likely to get your dates read incorrectly. Though I will say, you probably still won't get them correctly. Just that's the nature of working with dates in R. They're just a messy data type to work with. The other thing they do well is they don't change column names. People often get frustrated by this in R. Remember I said you can't start a variable name with a number. If R encounters a column in your spreadsheet that starts with a number, it'll often just add an X to it. Where this library has found a way with some special backslashes to keep the variable names as what matches the spreadsheet, even if the variable name is not a normally valid variable name. The only reason you would want that is if you're bringing a big data set into R to do some manipulation on a small part of it, then you want to write it back out. I don't want to have to rename 40 columns that I didn't use because I was just making a small change to one. So it keeps bad variable names in their original format. Though if you're going to work with them, you should if you're going to work with them, you should fix the variable names eventually. So let me run this. So the functions we can do on a Tibble. The three ones we'll focus on today are filter, select, and mutate. Start with filter. So filter is how we can subset rows. We tend to subset rows based on some sort of like Boolean logic for those subjects. So you can see that if I print the full data set, one of the other things I like about Tibbles is the first line is, it says this is a Tibble. It has this number of rows and this number of columns. Lets you quickly check the size of your data set. So that's what my full data set looks like. Oops. If I run filter for everyone where sex equals male, I've got the 2 equal signs because that's how Boolean logic works in R. That gives me just the subjects that are male. You can see the next example is the same. I'm running it on sex equals female. The only difference here is that I use the pipe function. So rather than passing dat as the first argument to filter, I piped that result into filter and got all the females in the data set. And your Boolean logic there can be as complex or as simple as you want. So you can see here, where's my third example? This is, I filtered to the males with BMI category of obese. That is, when you separate it by comma, it's an and, so that's male and obese. If I use the or operator, that vertical line, that's an or operator. So that would give me, if I want everyone that's obese or overweight, so that's all the BMIs over 25, I can just do it with that vertical operator. So filter uses Boolean logic, uses that true false logic to get the rows to subset the data based on the subjects we're interested in. So where filter selects your rows, select gets your columns. So select will get you all the variable names, and it's usually with select there are some, we can get creative with this, but usually we're just listing the variables we want. So if I want to pull out BMI group, their smoking status, and sex. Oh no, you can clean smoking status. Did I know that? Oh, I guess not. Okay. You can see that gives me the full tibble, all 4,400 rows, but then only the 3 variables I'm interested in. There are some complex, like you can get a little creative with the variables you select. So for example, if you look at the full Framingham data set, there are a bunch of different time variables that are like time is how long they're followed. And then all the other ones are like time AP is how long until they experienced AP. I don't know what AP stands for. Time to MI is how time to their first myocardial infarction, time to coronary heart disease, time to stroke, time to CVD. It's a good survival data set. That's why we use it. You okay? Yes. So if you're installing the tidyverse for the first time, it's going to take a minute. It's a big data set. So it requires installing 8 libraries, but some of those libraries are going to install additional libraries. Like it installs ggplot2, which in turn I think installs 6 or 7 libraries. So the first time you install tidyverse could take a minute. Yeah. So if you look at in the course website, and we won't talk about how this works until next class, but briefly, if you want to run through this code. Oh, okay. Okay. Did I assign it? Let me see what I did. Tools. Yeah, this command. Yeah, we're going to play with this in a second once we get through the third one. Because the last command we'll talk about is mutate. Mutate is where you can create variables. The nice thing about mutate is you don't have to do all the $sign referencing, so it's a little cleaner. So you can see that I took my data set, I selected the 4 variables I want, and then I created the variables each on their own line. Note that there are commas at the end of each line, so they don't have to be on their own line, but it's just way easier to read that way. So you can see that I'm creating variables. I turn death into a factor variable. I create the BMI categories. Also note that this is sequential. So even though this is all within the same function, as soon as I create BMI groups, the next line can reference a variable I just created. So it doesn't all have to run for the variables you created. They're done sequentially. So you can use variables you created in future variables. Oh, really? So this bracket's throwing you off? Go back up to that one. Yeah, so where my starts with, that was the select command, so it should be right here. This one. So select is a function, so it needs a closing bracket to match its opening one. And you can actually, this is going to happen to you a lot. One of the it's R implemented it as thinking they're being helpful, and I find it so when your mouse is, or when your cursor is after a bracket, it will highlight the bracket it matches. So if I had an extra one here, so that one's matching that. If I had this one, it's not matching anything. So if I try running that, I get an error because I have an extra bracket. So it's possible you have an extra bracket somewhere. It's always hard to track down why or where you have extra brackets, because losing a bracket in one place will throw off all your functions, which could really mess things up. And it's often it tends to usually be caused more by mutate than by select, because you'd often just have so many brackets flying around. The other thing is that when I open a bracket in RStudio, it automatically creates a closing bracket, which it thinks is being helpful. I actually find it kind of annoying, because if I then type a closing bracket, it types over the bracket it created. But if I wanted to insert a bracket, sometimes instead of inserting a bracket, it will type over the bracket I created. So you often have to insert brackets at the end of a set of brackets. So all that to say that when you're typing a lot in RStudio, if you're not paying attention, which you're sometimes not when you're typing all these functions, and you go to run it, you'll often be stuck either missing a bracket or having an extra bracket. Missing a bracket is actually more frustrating. So if I try and run this missing a bracket, I get that. And the pluses there mean that what I was typing is not done yet. And because white space doesn't matter, R isn't trying to execute this yet, because it doesn't think the command is done. I need to cut it off. So when this happens, so I think, oh, stop button's not even there. I mean, you can do something like that. That'll always kill it. But if you end up here, I often just start sending brackets until it decides to end. But if you get stuck in that situation, you're probably in trouble. It's probably going to break by the time you get it to execute. I want to take a break now. Yes. All right, we'll come back to joining and transforming data in a second, but I'll give you a little time to work on that. So there are two data sets, BP subjects and BP measures. Get them read in and get them formatted appropriately, and then we'll talk about joining them and pivot and manipulating them to longer and wider if we have time. If you want all the code from this third section, it's in, I didn't have a chance to, because we'll talk about how these files work next class. I should have made a .r file. This so1.03.rmd file, if you open that up, that's called a markdown file. That's how we'll do our functional reporting that mixes analytics and reporting in a single file. For now, because I haven't explained it to you, if you look at it, you can see it's go over there. It has R code that's encased in these called no web. I don't know what they're called, markdown tags, I guess. But that's all the R code. Everything outside that is reporting code. Don't worry that much about the reporting code, but if you want to steal the R code from that HTML file, feel free. You could also just open the HTML file, the HTML version itself, and copy the code out of that. Either one would work fine. But we have time. Let's take 10 minutes to work on just reading those two data sets in and getting them formatted, and then we'll talk about manipulating data. I want to make sure you guys have a chance to play with these tidyverse functions in it. And I'll peek in online. Any questions online? Giara has to head out, but that's about it. Yes. So yeah, I'll make this recording available hopefully later this afternoon, assuming that Teams makes it available to me that quickly. Oh, the joining? Yes, if you don't tell it what to join on, it will match all the variables, all the matching variable names. But you can tell it to just match on ID. And if you do that, it will maintain the duplicate variables in each one and apply a suffix to them. So the default, like if you match on ID, and then if you've got sex in both variable and data sets, it would add a sex.x from the first data set and a sex.y from the second. Did you use the merge command? Okay, the merge is fine. I kind of forget how it works. I like if you scroll up in the HTML there to the ones that the left, right, inner, and full join. So it's left underscore join, right underscore join. The join functions just seem to do a little, like all tidyverse functions, just a little more intuitive. And they also, I find that they need less specific manipulation than merge. But merge works as well. Often it's a matter of did you do a left join or a right join? So talking to the principles of join. So if you look at the top of there's a good, if you open 6 at the top, just at the bottom of 6, I list. There's a guide here. I think this is the one I cribbed all the answers from, isn't it? Yes. My favorite thing about this tutorial is the little GIFs he's done demonstrating the left to right, what a left join, a right join, an inner join, and an outer join are. It helps conceptualize what we mean. So I said outer, I think they call it full. But the idea when you're doing a left join of like what it does with duplicate 2s, or what it does with, you can see here, subject 4, there is a subject 4, but they weren't included in the merge because I did a left join, so I'm only maintaining everyone that exists in the left data set. So because 4 doesn't exist over here, 4's dropped there. Merge is capable of all those commands. I just forget what the default is. I like having them each one a different name because it lets you avoid making doing the wrong merge. All right. All right, so we're able to get those two data sets read in, the BP measures. And so for the cleaning, I like the str and the describe functions as the two easiest ways to do that. If you look at the str first, ID I'm sure is fine. I barely do any cleaning on ID. Sex, it looked like it was read in as a character, and there might be some problems. We see lower and uppercase letters. Age looks probably okay, and enroll date actually got read in as a date, which I'm surprised by. So if I do the describe function on it now, because there's only four variables, I'm not worried about all the output. We can see that ID doesn't matter. Sex, we've got a problem where female and male are coded as both lowercase and uppercase. And then age looks okay. A little worried about the 132-year-old and the 160-year-old. That doesn't seem right. Something has gone wrong there. In terms of what we do about that, I'm not going to do anything about it right now. In reality, what I would probably do is try and figure out if the 1 is a typo. Because I could just set them to missing, but that's throwing out data where losing their ages means that they're going to be left out of regression models. And like 132 and 160 obviously right, but it would be nice to try and retain them in some way if I can figure out where the typo is. But I don't have the time, or I don't know what I also made up this data, so we can't go back to source to figure out what the mistake is. But I would want to go back and figure out what that mistake is. I need to address it, but I'd prefer not to address it just by setting it to missing, because that's ultimately going to throw out those subjects where it could be that they're 32 and 60 and there was just a typo, or maybe they're 11 and like 14 and their age was written in months rather than years or something. And then enroll date actually get read as a date, which is surprising. But sometimes you get lucky and that actually is a date object. The nice thing about when you can get things formatted as a date or a date time object in R is that you can start doing math on them. So I could subtract one date from another date to get the number of days between them. But getting them into that format can sometimes be a pain just because they're not written correctly. So what I'm going to do is probably use the mutate function. And sex is the variable I have to fix in dat01. So how would you go about, what would be your approach if you want to fix that character variable? Because there are two different ways we could approach this. Because it's a character, we want to convert it to a factor, but we've got both uppercase and lowercase m's and f's. Yeah, so we need to recode it. And the two ways we can do it, we can either switch all the letters to a single case, or we can turn it into a 4-level factor and then change it to a 2-level factor. And I'll show you how to do both of those. So 602 equals 2 upper. So there's a function called 2 upper. When you apply it to a string function, it just makes it an uppercase string function. So in this case, if I apply 2 upper on that variable, we can see that. Also, you'll notice, so what I'm doing here, I have dat01 piped into all my functions. I'm not assigning it to anything. So I'm running my data set through a bunch of functions, and it just prints out to the output. I will eventually, once I'm done all this formatting, I'll assign this object to the dat01 object again to overwrite it. But I don't want to overwrite it now because I'm just doing a bunch of experimenting. So once I'm sure all my cleaning is correct, then I will assign it to an object permanently to save it. So yeah, you can see with this 2 upper function, I created an uppercase version of the lowercase letters, and when they were actually uppercase already, they stay uppercase. So then I could, if I want to do it that way, I could do effect equals a factor of x dot upper. Now I could, if I wanted to, with this factor function, pass in like levels equals concatenate mf and labels. But if you don't pass those in, it just uses kind of the default values there. And I'm happy with m and f as my 2 levels. And I don't really care at this point which one my reference is. So I'm just going to leave it like that. So that you can see I've created a factor variable. All that when we're looking at this, the difference we see in the tibble is that one is characters and the other one is factors. So that's one way to do it. The other way to do it would be to equals factor of 6. So this creates a factor version of that original variable. You can see that it's a factor variable here, but it has 4 levels. And then using a specific function that I had to Google because I didn't know what this function was. So I Googled R, create a factor and combine levels. And then you can see that there are a bunch of different answers from Stack Exchange. I mean, your Google searches might not be as Stack Exchange biased as mine are. I click on it a lot, so Google knows that I like it, so it goes to it a lot. But if you go down to the answers, there's a function called FCT collapse, and that's from the forcats package, which is one of the packages that's part of tidyverse. So when you load tidyverse, that package gets loaded. So you can follow their instructions. And I'm sure if I scroll down on this thread, there are a bunch of different options. The car function recode. I don't love that one. We can do some if-elsing. There are a bunch of different solutions, but I think usually with these kind of simpler procedures, the top answer is the best. So I think FCT collapse makes the most sense. So I could do effect equals FCT recode factor 4. Wouldn't that work? Did I get the name of the function right? No, I used the wrong function. Yeah, I can re-upload this with the extra code on it. That's easier than you trying to transcribe it. Yeah. Yeah. Okay. So that worked. So yeah, 2 different ways to do it. I think in reality, the way we would do it is 6 equals factor 2 upper 6, like that. Like we would do it in one command, not creating any new variables. And what I'll probably do is 36 age date. So I'm going to, after I've created all these variables, I'm going to select just the variables I want, which were ID, sex, age, and roll date, and not keep any of those variables. I want to leave it there so you guys can see it when I upload it, but I'm not going to use it for anything. So now that I'm happy with that, I'll assign it to data01. And you can often, so sometimes what I'll do is I'll read my data into a .raw object. Doesn't mean anything. It's just what I'm choosing. So where like my .raw object is the original data. So if I want to go back to that, that means that I can keep rerunning this command and it'll always work. You can do that if that's often a good practice if you want to if you're going to be doing a lot of iterations over your data cleaning, just to make sure that you don't break things. So that's one way to do it. You don't have to do that. And I don't always do it, but if I'm going to be doing a lot of data cleaning and data manipulation, then that's what I'll do. So I think actually I'll stop there. I want to talk next class. We'll start with sections 6 and 7 of the of this. So I want to talk. Yeah, this one, right? Yeah. I want to talk about joining and pivoting. So joining how to join 2 data sets, then pivoting how to go from wide to long and long to wide. We'll also do a little bit of a recap on those pipes and things. And then we'll also talk about how to actually do stats. So we'll spend some time going over what we do in biostats 1 and 2. So t-tests, chi-square tests, linear regression, logistic regression, all those kind of regression methods. Poisson regression's actually, once you learn logistic regression, Poisson regression's really easy. It's the same command, just a different family. So that's it. I'll stick around for a couple of minutes if anyone has any questions. Otherwise, I'll see you all on Friday. Yeah, it's so the closest thing certainly for data manipulation would be the tidyverse. That being said, the structure of Stata's help files, like especially their help PDFs, like it's a lot of them are teaching you like they're teaching you logistic regression while teaching you how to do it in Stata. There's nothing quite that good because all of our libraries are user generated. The quality of the help files varies drastically, but I would say all of the help files take a very technical approach to. Now what you'll find is R has a journal. So for a lot of these libraries, especially some of the more complicated ones, they'll have journal articles associated with them, and those will really guide you through. But in terms of like that guided like methods and technique, yeah. I would say that the tidyverse textbook's your best bet. But especially because I switched to the tidyverse about 3 years ago, actually, just after I wet my whistle teaching this course for the first time, and now I use it for everything. But I found that, and I still find that I'm Googling a lot because there isn't like I know what I want to do, and if you want to do it, you can do it. But knowing what the commands are, and the other frustrating thing you'll find is, especially when you go to other libraries, the consistency of arguments is just not there. So, like, it's great when you find the function in the tidyverse, and most of it will be there. But when you find it outside the tidyverse, you're like, oh man, I hope this is well written. I hope the help file has good help. I hope they've chosen naming conventions. I hope they're object. Like there are quality issues with some of the libraries, but in general, everything you can do. But you like I said, you spend a lot of time on Stack Exchange, a lot of time on the STHDA or STDHA, whatever they're called, with their guides for like how to do. I find particularly for things like ggplot, which we'll talk about the graphics next time, where like I know that there are commands to do all these graphics, and I just don't know what they're called. Oh, really? Shoot. Oh. All right, I'm going to shut this off.